Look up into the quiet dark of the night sky, a vast and silent ocean stretching into forever. Every point of light you see is a story, a sun telling a tale from a long, long time ago. The light from the nearest stars began its journey years before it reached your eyes, a postcard from the past. But some light has traveled for millions of years, from galaxies so far away they are mere whispers in the darkness. This is the secret of the cosmos. To look out into the distance is to look back into the deepest history. We have built great eyes of glass and metal, instruments designed not just to see, but to remember. These telescopes are our time machines, collecting ancient light that holds the memory of a younger, different universe. With every image they capture, we turn back another page in the great cosmic story, reading chapters from before we existed. We have looked back 1 billion years, and then 10 billion years, seeing galaxies in their chaotic, youthful stages. But there is a limit, a wall of time we have always strained to see beyond, a final frontier of cosmic history. We are searching for the very first page, the moment before the story of stars and galaxies even began. Scientists believe we are on the edge of a great precipice, a moment of profound and unprecedented seeing. The year 2025 is being whispered among them not as a date, but as a destination in time. It is a year where our most powerful instruments might finally gather the light from the beginning of everything. Imagine it, a signal that has been traveling for over 13 billion years is about to arrive at our doorstep. We are preparing to answer the door, to finally witness the light from the universe's own dawn. This is not about seeing with our eyes, but with instruments so sensitive they can feel the oldest echo in the cosmos. An echo of the first moment, a time when the entire universe was smaller than a single grain of sand. Before the first star ignited, before the first galaxy spiraled into existence, there was only light and potential. That is what we are looking for, the afterglow of creation itself, the cosmic birth announcement. Our technology has finally caught up with our oldest questions, building a bridge to the very edge of time. What will it look like? This first baby picture of our universe. This message from the ultimate past. Will it be a pattern, a color, a temperature, a map of the universe in its very first second of life? The data will flow from the heavens, a silent stream of numbers that holds the secret of our own origins. It will be a message that confirms not just how the universe was born, but that we are capable of understanding it. This quest unites us, a species on a small blue planet, looking up and asking the same fundamental question. Where did all of this come from? What happened in the very beginning to set this grand spectacle in motion? We have been standing on the shore of the cosmic ocean, and now we are preparing to see the other side. A new generation of cosmic explorers, our telescopes, are our vessels for this impossible journey through time. The year 2025 could be the year we receive the message in a bottle, thrown from the Big Bang itself. The light we are trying to see is no longer visible in the way we think of light. It is stretched and faint. It has become a whisper, a faint warmth spread across the entire sky, a ghost of the primordial fire. To see it, we must listen to the universe in frequencies our eyes could never perceive, in the quietest radio silence. The promise of 2025 is that our instruments will finally be quiet enough to hear this ancient cosmic lullaby. This is not just a scientific pursuit, it is a deeply philosophical one, touching the core of our existence. To see the beginning is to understand the context for everything that followed, including our own improbable arrival. We are the universe made aware of itself, and we are finally building the tools to look at our own reflection. This moment has been building for centuries, a legacy of every astronomer who ever looked up in wonder. From Galileo's first small telescope to the continent-sized arrays of today, the journey has led to this threshold. The universe has been patient, holding its secret for 13.8 billion years, waiting for someone to be able to see. And now, as we approach this new epoch of discovery, the cosmos prepares to reveal its earliest truth. The potential discovery is not a single event, but the opening of a new window into a previously unseen reality. It is a glimpse into the physics that governed the first moments, the rules that wrote the cosmic code. This is humanity's ultimate archaeological dig, sifting through the fossilized light of the Big Bang itself. Every other discovery has told us what the universe is, but this one will tell us how it came to be. As the instruments are calibrated and the data begins to flow, a quiet anticipation settles over the scientific world. We are standing at the edge of knowing, peering into the dawn of time, waiting for the light to arrive. The answer to the oldest question may not be a word, but an image of unimaginable age and beauty. And in that image, we will not just see the birth of the universe, but the start of our own long story. The stage is set, the cosmos is the theater, and we are the audience about to witness the opening act. The method for this profound observation is not a simple act of pointing a lens, but a form of cosmic archaeology using gravitational waves. These are not waves of light, but ripples in the very fabric of space-time itself, predicted by Einstein a century ago. Generated by the most violent events, they travel unimpeded across the eons. The Big Bang itself would have been the most violent event of all, shaking the newborn cosmos and sending out a primordial hum that still echoes through reality today. To detect these unimaginably faint tremors, observatories on Earth and future arrays in space are being designed with almost impossible sensitivity. These instruments are not telescopes but cosmic seismographs, listening for the faint, residual vibration of creation. The year 2025 represents a milestone in their projected sensitivity, a point where they might finally filter out all the noise of the modern universe, colliding black holes, merging neutron stars, and isolate the pure, monolithic signal from the beginning of time, the ultimate cosmic background sound. This primordial gravitational wave background is the holy grail of cosmology. Unlike the cosmic microwave background radiation, which shows us the universe at 380,000 years old, gravitational waves could show it to us at just a tiny fraction of its first second. Light could not travel freely then, as the universe was a hot, opaque fog. But space-time itself was transparent to its own vibrations. Seeing this signal would be like hearing the sound of a bell being struck, rather than just seeing it after it has stopped ringing. Scientists anticipate the signal will reveal a universe in the grip of a process called inflation. This is the theory that in the first sliver of a second, the universe underwent a period of exponential expansion, growing from subatomic size to cosmic proportions almost instantly. This violent stretching of space-time would have generated a very specific pattern of gravitational waves, a unique signature. Finding that signature in the data would be the first direct evidence of inflation, confirming our most successful, yet unproven, theory of cosmic origins. The map derived from these waves would be unlike any astronomical image ever created. It would not show stars or galaxies, but rather the quantum fluctuations of the nascent universe, the tiny variations in energy in the primordial soup that were magnified by inflation to cosmic scale. These tiny ripples seen in the gravitational wave data would be the very seeds of all future structures, the blueprints for the great clusters of galaxies that fill our universe today. We would be seeing the cause, not just the effect. What makes 2025 a focal point is the convergence of multiple next-generation experiments coming online and reaching peak sensitivity. Projects like the Laser Interferometer Space Antenna, or LISA, and advancements in ground-based detectors are all part of this global effort. The sheer volume of data they will collect, processed by advanced artificial intelligence, creates a statistical likelihood of discovery. It's a coordinated, multi-pronged assault on the deepest mystery, a technological crescendo that has been building for decades and is finally ready to perform. Beyond just seeing the beginning, this new window could reveal physics beyond our current understanding. The precise nature of the gravitational wave signal might hold clues about the fundamental forces of nature at energies far beyond what any particle accelerator on Earth could ever achieve. We might find evidence of new particles, extra dimensions, or even hints about what, if anything, came before the Big Bang. The birth of the universe could become a laboratory for testing the absolute limits of physical law. The successful detection would be a profound moment of unification in science. It would connect the impossibly large world of cosmology with the impossibly small world of quantum mechanics. For the first time, We would have observational data from an era when the entire observable universe was a quantum object. The grand theories of everything, which have lived in the realm of mathematics and speculation, would finally have a tangible, physical test to pass. A definitive filter, separating elegant ideas from physical reality. But what if we find nothing? The absence of a signal could be just as revolutionary, though in a different way. It might mean our theory of inflation is incorrect, sending theorists back to the drawing board to imagine a different kind of beginning. A null result would force us to confront the possibility that the universe began in a way we have not even conceived of yet. Science progresses not just by confirmation, but by the graceful collapse of beautiful theories under the weight of silent, uncooperative data. The search is a testament to human persistence, a multi-generational relay race of knowledge. The scientists of today are building on the foundations laid by thinkers throughout history, from ancient philosophers to Newton, Einstein, and Hubble. This potential discovery in 2025 would not belong to one person or one country, but would be the shared inheritance of our entire species' relentless curiosity. It is the culmination of our innate desire to understand our place in the grand, silent cosmic narrative that surrounds us. The light and waves we seek are known as relics of the early universe. Like ancient fossils embedded in stone, these signals are fossils of time, carrying information from an era that no longer exists. The cosmic microwave background is one such relic, but the primordial gravitational waves are far older, from an even more primordial geological stratum of cosmic time. They are the most pristine messengers we could ever hope to receive, completely unaltered by their 13.8 billion-year journey across the expanding fabric of the cosmos. This endeavor requires a form of cosmic listening on a scale that is difficult to comprehend. The detectors must be so still, so isolated from terrestrial vibration, that they can register a distortion in spacetime thousands of times smaller than the nucleus of an atom. It is an engineering challenge of the highest order, pushing materials, science, laser technology, and vacuum systems to their absolute limits. We are essentially trying to build the quietest place in the universe in order to hear its very first sound. The potential data won't arrive as a clear picture, but as a complex stream of statistical noise. The great challenge for astrophysicists will be to develop algorithms powerful enough to find the incredibly faint, coherent signal of the Big Bang, buried within the chaotic noise of countless other cosmic events. It is like trying to hear a single pin drop in the middle of a thunderstorm. The seeing is an act of sophisticated computational extraction, a ghost in the machine of the cosmos. If we succeed, we may solve one of the great paradoxes of cosmology, the horizon problem. This is the mystery of why the universe looks so remarkably uniform in all directions, even though opposite ends of the cosmos should never have had time to be in contact and reach the same temperature. Inflation theory solves this by suggesting they were once in contact and were then violently ripped apart. Finding the gravitational waves from inflation would be the ultimate confirmation of this elegant, mind-bending solution. Another mystery this discovery could illuminate is the nature of dark energy, the enigmatic force causing the universe to accelerate its expansion today. Some theories suggest the energy that drove inflation at the beginning of time is related to the dark energy we observe now. The data from the universe's first second could provide the crucial link, a clue that connects the cosmic dawn to its eventual twilight, giving us a more complete picture of the universe's entire life story and its ultimate destiny. Consider the perspective shift this would bring. We currently see ourselves as living in a universe of things, of stars, planets, and galaxies, but a glimpse of the beginning would reframe our reality. We would see that our universe is fundamentally a universe of events and information, a place where the physical structures we see are just the long, slow consequences of a single, explosive quantum event that happened in an instant. The substance of reality is not matter, but the information encoded in space-time itself. The instruments we build for this search are some of the most collaborative scientific projects in human history, involving thousands of scientists from over 100 countries. They represent a kind of planetary intelligence focused on a single transcendent question. In a world often defined by division, the search for our cosmic origins is a silent, powerful force for unity, reminding us of our shared identity as inhabitants of a single, fragile world looking out into the same magnificent, mysterious darkness. The journey of a single primordial gravitational wave is a story in itself. Born in the first fraction of a second, it has traveled through the era of first light, witnessed the birth and death of the first stars, passed through the spiral arms of countless young galaxies, and journeyed through the vast empty voids between them. For billions of years, it has been on a collision course with a small, rocky planet that wouldn't even exist for most of its journey, to finally arrive in 2025. This moment would not just be a scientific revolution, but a cultural one. For all of human history, our creation stories have been the domain of mythology and religion, beautiful narratives born from the human imagination. For the first time, we would have an observational, empirical creation story. It would not invalidate other beliefs, but would provide a new, shared foundation for all of humanity, a common origin story written in the universal language of mathematics and physics. There are even more exotic possibilities. Some theories, like the ekpyrotic model, suggest our universe was born from the collision of higher dimensional membranes, or brains. This event would produce a different gravitational wave signature than inflation. If we detect that pattern instead, it would imply the existence of other dimensions and other universes right alongside our own, a vast multiverse of which our Big Bang was just one of many cosmic events. The discovery could expand our reality infinitely. The precision required is staggering. As these gravitational waves pass through Earth, they stretch and squeeze everything by a minuscule amount. A detector arm, several kilometers long, might change in length by only the width of a proton. Measuring this requires lasers of incredible stability and mirrors polished to near atomic perfection. It is a testament to our species' ability to manipulate the physical world on both the grandest and most delicate scales, all in the service of answering a single question. Let your mind settle on the sheer scale of time involved. If the entire 13.8 billion-year history of the universe were compressed into a single calendar year, our galaxy would form in September. The dinosaurs would appear on Christmas Day. All of recorded human history would take place in the final 10 seconds before midnight on New Year's Eve. We are trying to see what happened in the first nanosecond of January 1st. We are reaching back across the entire cosmic year. This potential observation is also a race against our own noise. As our civilization becomes more technologically advanced, we fill the planet with seismic and electromagnetic noise, making it harder to hear the faint whispers of the cosmos. The scientists building these experiments must find the quietest, most remote locations on the planet, and even then, they must use sophisticated software to subtract the noise of a distant truck or a gentle earthquake from their data, all to isolate a signal from the beginning of time. The philosophical implications are profound. If we confirm that the universe began from a random quantum fluctuation, it would reinforce the idea that our existence, and all the structure we see, is the result of chance and physical law, not predetermined design. It would place humanity within a cosmic framework that is at once magnificent and humbling, a beautiful accident born from a set of incredibly fortunate initial conditions. Our significance would come not from being planned, but from being aware. The visualization of the data would be a challenge for artists as much as for scientists. How do you represent a pattern of vibrations in spacetime from before light even existed? It might be rendered as a soundscape, a complex chord of cosmic harmony, or perhaps as a tactile map of textures. This discovery would push the boundaries of how we communicate knowledge, forcing us to invent new languages to describe a reality so far removed from our everyday sensory experience. This pursuit is driven by a deep-seated human need for closure. To complete the circle of knowledge, we have discovered the laws of physics that govern our world, the evolution of life, and the structure of stars. The origin of the universe itself is the last and greatest missing piece of the puzzle. Finding it would be like finding the first page of a book we have been reading from the middle. It would provide the ultimate context for every other piece of knowledge we have ever gathered. Even now, as you listen, prototypes and precursor experiments are running, refining the techniques and narrowing the search parameters. Every day, teams of researchers are solving small, incremental problems, calibrating sensors, and improving algorithms. The potential breakthrough of 2025 will not be a sudden flash of insight, but the result of millions of hours of patient, meticulous, and often frustrating work by a global community dedicated to pushing the boundaries of what is possible to know. This search forces us to confront the idea of a cosmic horizon, not just in space, but in time. The gravitational wave background from the Big Bang might be the absolute earliest thing we can ever hope to observe. Beyond it lies the moment of the singularity itself, an event where our current laws of physics break down completely. We may be approaching the ultimate wall, the point at which the universe becomes fundamentally unknowable, where science must give way to pure philosophy. The energies present in the first second of the universe were trillions of times higher than anything we can study on Earth. The universe itself was the ultimate particle accelerator. The patterns frozen into the gravitational wave background from that time are therefore a priceless dataset. They are a direct window into the behavior of matter and energy under conditions we can never replicate. In a sense, the universe performed the one-time experiment for us, and we are only now building the tools to read the results. To be alive at this particular moment in history is an incredible privilege. We are the generation that may transition from wondering how the universe began to knowing how it began. This knowledge will change our perspective forever, much like the first images of Earth from space changed our perception of our planet. Seeing the cosmic dawn will give us a new, deeper appreciation for the immense, ancient, and intricate reality into which we have been so briefly and so beautifully born. This quest for the beginning is also, in a way, a search for simplicity. The universe today is a place of immense complexity, with a zoo of particles, forces, and structures. But cosmological theories suggest that at the very beginning, in the first moments, the universe was profoundly simple. There may have been only one unified superforce and one type of particle. To see the beginning is to see the universe in its most elegant, unified state, before the beautiful complexity of today unfolded. The teams working on these projects are also developing new forms of open science, sharing data and analysis techniques freely across international borders. The sheer scale of the challenge necessitates a level of collaboration that transcends politics and competition. The discovery, if and when it comes, will be published with an author list thousands of names long, a document that symbolizes a new kind of collective human endeavor, a testament to what we can achieve when we work together towards a common transcendent goal. Let your mind rest on the quiet patience of the cosmos. For billions of years, the evidence of our origins has been washing over our planet, encoded in waves of light and spacetime. It has been here all along, waiting. It is not the universe that has changed, but us. We have slowly, over millennia, developed the senses to perceive it. The story was always being told. We just had to learn the language and build the ears to listen to its faint, magnificent, and ancient broadcast. The confirmation of inflation would have a strange, almost dizzying implication. The same mechanism that created our universe would likely not have stopped. The theory suggests that inflation is eternal, constantly spawning new bubble universes with potentially different laws of physics. Our Big Bang would not be a unique event, but one of countless others in a vast cosmic foam of realities. Seeing the birth of our universe might be the first step to confirming the existence of infinitely more. This pursuit redefines the concept of discovery. It is not like finding a new continent or a new planet. It is the discovery of a boundary condition, the uncovering of the initial state from which everything else can be derived. It's less a discovery and more a deep act of cosmic remembrance, using the tools of physics to reconstruct a memory that is encoded in the very fabric of the space we inhabit. We are remembering our own deepest, most universal past. The potential clarity of this signal is what gives cosmologists hope. While many events in the universe can produce gravitational waves, the inflation of the universe should have created a stochastic all-sky background with very specific polarization properties. It would be an unmistakable fingerprint. If they see it, there will be very little ambiguity. The universe will have confessed its origin story, and the evidence will be clear for all to see, analyze, and confirm for generations to come. Think of the silence. For these instruments to work, they must be shielded from every possible disturbance. They are built deep underground or will be sent to the quietest orbits in the solar system, far from the Earth. In these places of profound physical silence, we are creating a metaphorical quiet in our own minds, filtering out the noise of the present to allow the faintest signal from the distant past to finally be heard. It is a technological form of deep, cosmic meditation. This entire scientific endeavor is a beautiful act of faith. Faith not in a supernatural being, but in the power of the scientific method, in the idea that the universe is comprehensible, and that through logic, mathematics, and careful observation, we can answer the deepest questions we are capable of asking. The year 2025 is a testament to that faith, a moment where our belief in our own capacity for understanding may be profoundly and wonderfully rewarded. When the results are finally analyzed, they will ripple through all of science, affecting not just cosmology but particle physics, computer science, and even chemistry. Understanding the initial conditions of the universe helps explain why the fundamental constants of nature have the values they do, which in turn explains why atoms are stable and stars can shine. The birth of the universe is not an isolated event. It is the anchor point for all of reality, the master key that helps unlock countless other doors. Let us imagine that moment. A small group of scientists in a quiet control room, watching as a final analysis completes. A line on a graph resolves. A pattern emerges from the noise. In that quiet, sterile room, a window opens onto the first moment of time. It is a silent, digital event that will fundamentally reshape humanity's understanding of itself. In that instant, we would become the first species on this planet to truly know where we came from. The quest doesn't end with this discovery. It opens a new chapter. The next generation of scientists will take this new map of the beginning and ask even deeper questions. Why did the universe begin with these specific conditions? What is the physics that governs the creation of universes themselves? Each answer in science does not close a book, but rather reveals a door to an even larger library, filled with more profound and more beautiful questions we had not yet imagined. The story is ultimately about light and its echoes. First, we saw the visible light from nearby stars. Then we built telescopes to see the infrared and ultraviolet light from distant galaxies. We then learned to see the microwaves left over from the hot plasma of the early universe. Now we are learning to see with gravity itself, to perceive the oldest, most fundamental echo of all. Our senses have expanded, and with them, the boundaries of our known universe have expanded as well. This journey to the beginning of time makes our own terrestrial concerns seem small, yet it also makes our existence seem infinitely more precious. In a universe governed by vast, impersonal forces, the emergence of a consciousness that can comprehend those forces is a remarkable and perhaps exceedingly rare event. Our ability to even ask the question of our origin is what gives our small, fleeting lives a measure of cosmic significance. We are the universe's way of knowing itself. The coming years will be a time of quiet and profound anticipation. As the instruments are commissioned and begin their long, patient stare into the darkness, we will be waiting for a message that has been on its way to us since before the Earth was formed. It is a humbling thought. To exist at the precise moment in a planet's history when its inhabitants become capable of witnessing the dawn of time. We are living in the age of first contact with our own creation. This is the power of a good question. The simple query, where did we come from, has driven the construction of some of the most complex and ambitious machines ever conceived. It has united rivals, inspired generations of students, and pushed the very limits of our technological and intellectual capabilities. The question is the engine, and the potential discovery is not an end, but merely a milestone on an infinite journey of cosmic exploration that resides within the human spirit. As you drift into a state of rest, consider the immense stillness of deep space, a quiet that is not empty, but filled with the faint residual energy of the universe's birth. This ancient hum, this cosmic ghost, is a constant presence in all of our lives, passing through us every second. We are just now learning how to tune into its frequency, to hear the story it has been telling all along, a story of a violent, beautiful beginning from which all things have emerged. The search for the Big Bang's echo is a search for the ultimate silence. It is a paradox that to find the evidence of the loudest event in history, we must create the quietest environments possible. It is in this profound stillness, this technological meditation, that we can finally perceive the truth. The answer to the universe's most dramatic moment is not a shout, but a whisper that has been waiting patiently for 13.8 billion years to be heard. The knowledge we might gain is not just for scientists in labs, it is for everyone. It is a new piece of our collective human story, a fact that will be taught to school children for centuries to come. It will become part of the bedrock of our understanding, a shared reference point for our species. To see the beginning is to give our future generations a more complete and awe-inspiring sense of their own cosmic heritage, a story grander than any we could have invented. So as we look towards 2025, we look with a calm, scientific hope. Not for a miracle, but for the predictable and beautiful unfolding of the scientific method. We are ready to receive the oldest message in existence, to read the first sentence in the cosmic story. And in doing so, we will not just be seeing the birth of the universe, but we will be witnessing a profound milestone in the maturity of our own species. We are growing up and finally understanding our home. The universe does not keep its secrets maliciously. Its truths are written in the language of physics, available to anyone with the patience to learn and the instruments to see. We are on the verge of reading its most foundational scripture, a text written not in ink, but in the vibrations of space-time itself. And its message, carried across billions of years, will finally arrive, telling us of a brilliant, simple, and explosive moment when everything, absolutely everything, began.